All right, calculus kids. Let's find some extrema. Okay. All right, so my question is to find the extrema for the function f of x equals x to the 2/3 power on the closed interval from -2 to 3. Okay. So extrema means, you're finding mins and maxes. They could be absolute mins and maxes. They could be local mins and maxes, okay? All right, we have this thing called the extreme value theorem. And the extreme value theorem states that if you have a continuous function on a closed interval, you're guaranteed to have both an absolute min and an absolute max, okay? And this function that I've chosen is a continuous function, and it's on a closed interval. So we have that guarantee. There will be an absolute max and there will be an absolute min. Okay? So extrema can occur at 2 points, or at 2 possible locations. They can occur at critical points or endpoints. Okay? So let's find critical points. Critical points are going to come from our derivative. Okay? So first we must take the derivative. So our derivative here is going to be 2/3 x to the -1/3 power. Now I want to actually use that derivative. Okay, so I'm going to rewrite this derivative as 2/3 times the cube root of x. So there's our derivative. Okay, so what does that mean as far as critical points go? Okay, well, critical points are going to be located where the derivative is either equal to 0 or where the derivative does not exist. Okay, so we want to make ourselves a little chart here. Okay, so the derivative is going to be equal to 0. Let's see. All right, so for critical points, the derivative is equal to 0 or the derivative does not exist. So we have a fraction here, right, for our derivative, 2/3 cube root of x. For a fraction to be equal to 0, the top must be equal to 0. All right, the top of our fraction is always going to be 2. It's never going to be 0. So we're not going to get any critical points from that. Now, the bottom of our fraction will be 0, and that would make the derivative have division by 0, and that's bad, right? So the derivative doesn't exist when the bottom of the fraction is equal to 0, and that will happen when x equals 0. So there's one critical point. All right, we have endpoints as well, right? We're on a closed interval, so we have endpoints at both -2 and +3. So there's actually 3 possible locations for extreme values. Okay, 0, -2, and 3. Okay, so let's take a look here. Okay, all right, we want to find the function value at each one of these. Okay, the function value. Okay, so what is f of 0? What is f of -2? And what is f of 3? So if we plug those into our function, if I plug in 0, the value of the function, not the derivative, the value of the function is 0. Okay? The value of the function at -2, if I plug in -2, will be the cube root of 4. And if I plug in 3 to the function, I'll get the cube root of 9. So now remember, I said that this problem satisfied the extreme value theorem. Okay, so that means it's continuous on a closed interval. You're guaranteed to have an absolute min and absolute max. Okay, so just looking at these function values, you can tell me right now what the absolute min and max are. The smallest function value is 0, and it occurs at 0. So this will be the location and the value of our absolute minimum. Okay? And then the function value of cube root of 9 is the biggest function value. That'll be the value and the location of our absolute maximum. Okay? But what about that value in the middle? Okay, the value at -2. Okay, it could be a local max or a local min. So let's go to this graph that I have over here. This is the graph of the original function. Okay, there are three places to look at in this graph. We want to zero in at x equals 0, x equals -2, and x equals 3. Okay, that's where we have endpoints. Okay, -2 is an endpoint to the function. Okay, +3 is an endpoint to the function. So we're only looking at this portion of the function right here. Okay, it's the only part we're looking at. Okay, so do you agree that at x equals 3 we have an absolute maximum? Okay, it sure does look like that. That's the highest point on the graph, okay, on this closed interval. Okay, do you agree that at 0, okay, at 0, we have the lowest point on the graph, so that would be the absolute minimum, okay? Now, my question is, what's happening over here at -2? Okay, is anything happening? Well, I say there is. I say that this is a local maximum, okay? So we also have a local maximum that's happening at -2, and the local maximum is equal to the cube root of 4. Okay, so this has been a problem that explains finding extrema, the process of using the first derivative to find mins and maxes. Okay, so hopefully this has helped if you're having a little trouble with it.